To observe the kinetic and gravitational potential energies of a freely falling object and to investigate the conservation of mechanical energy as it falls. Chapter 2. Equipment. Motion Sensor 2. Vernier Discover Freefall System. 3. Large Rod Base 4, 120 cm Rod 5, Multi-Clamp 6, 45 cm Rod 7, Motion Sensor Guard 8, Mass Balance 9, PASPORT Interface 10, Capstone Software 3. Introduction and Theory. 1. Gravitational Potential Energy, U equals mg h. 2. Kinetic Energy, K equals 1/2 mv squared. 3. Mechanical Energy, E equals U plus K. 4. Ignoring air resistance, the mechanical energy E remains constant as the object falls. 5. When a ball is dropped from rest, all its potential energy is converted into kinetic energy. 4. Setup. Step by step. 1. Measure the mass of the large plastic ball. 2. Attach the drop box to a support rod, ceiling, or other object at the desired height. 3. Connect the communication cable between the drop box and control box. 4. Plug in the AC adapter and connect to the control box. 5. Insert one of the timer switch plugs into the control box. 6. Attach a washer to the drop object with a release label. 7. Open the Capstone Software file energy1.ds. 8. Plug the motion sensor into the PASPORT interface. 9. Set the switch on the motion sensor to the person setting. 10. Place the motion sensor on the floor directly under the ball with the sensor element rotated to point straight up. 11. Suspend the large plastic ball from the drop box. 12. Move the control box switch to arm. 5. Procedure. 1. Start recording in Capstone Software. 2. Press the switch to drop the ball. 3. Stop recording. 4. Look at the graph of height versus time. It should be a smooth curve until the ball gets too close to the sensor. If the curve is not smooth for the fall of the ball, ask your instructor for help and redo the data run. 6. Analysis 1. Look at the table of height and speed data. Record the initial height of the ball and calculate the initial total energy of the ball. What is the initial E? 2. Find a point in the table where the ball is about 3/4 the way down. Record the height and speed of the ball and calculate the total energy of the ball E. 3. Repeat. Step 2 for a point 1/2 way down and 1/4 from the bottom. 7. Data and calculations. Table columns 1. H meters 2. V meters per second 3. U joules 4. K joules 5. E joules rows 1. Initial height 2. 3/4 height 3. 1/2 height 4. 1/4 height. Equations 1. U equals mgh 2. K equals 1/2 mv squared 3. E equals U plus K 8. Questions 1. Does the total energy for the ball stay about the same? Explain why or why not. 2. What effect would you expect air friction to have? 9. Graphs. 1. Attach height versus time plot. 2. Attach height versus velocity plot. Graph titles shown. 1. Height versus time. 2. Height versus velocity. 10. Results and discussion. Analyze your results and discuss. 1. Conservation of mechanical energy. 2. Sources of experimental error. 3. Effect of air resistance. Chapter 11. Conclusions. Summarize your findings and state whether the experiment supports the conservation of mechanical energy for a freely falling object. Main title experiment 8. Mechanics. Conservation of energy 1. Investigating the conservation of mechanical energy in a freely falling object.